Hello everyone, welcome back to my channel. In our previous video, we have seen some very important uses of distance versus time graph. We can consider those graphs similar to displacement versus time graphs because when the motion of an object is in a straight line, without any change in direction, then we can consider distance as well as displacement both as same. So the distance versus time graphs which we considered in our previous class, these graphs you can consider them for displacement also. Okay, instead of distance you can consider displacement. This is the displacement. Okay, so the distance versus time graphs as well as displacement versus time graphs both are similar when the body or the object is moving in a straight line without any change in the direction. Okay, now we will move to the next important set of graphs which are velocity versus time graphs. Okay, so this also gives us some information. Let us see what is the information that we'll get from each and every graph. If you observe the first graph, the graph is a straight line which is parallel to uh, time axis. So the graph is a straight line which is parallel to time axis. It indicates that the velocity is constant. Okay, so constant velocity, you can also consider this as uniform velocity. Okay, when this velocity is constant, if the displacement, for example, if you want to know, I will just draw a small graph here. If the displacement versus time graph, if this is displacement and this is time, if displacement versus time graph is a straight line passing through origin, then by differentiating this displacement versus time graph, you will get this velocity versus time graph. Okay, now observe, you have a uniform velocity. Uniform velocity means velocity is constant. Okay, so velocity is constant. Now if the velocity is constant, what about the acceleration? We know that the acceleration is a rate of change of velocity, dv by dt. If velocity is constant, this acceleration is zero. So for this particular graph there will be no acceleration, and we consider this type of motion as a motion which has uniform velocity. We also consider this as uniform motion. Okay, next, coming to the second graph, if you observe, the second graph is a straight line which is passing through origin. Now when you find the slope of this graph at any instant, you will get the same slope because it is a linear graph. Now what this slope, the slope of velocity versus a time graph, slope is nothing but generally change in y by change in x. So it is a change in y by change in x. So it indicates that we are finding change in velocity with respect to change in time. So the slope of velocity versus time graph gives us acceleration. Okay, now as the slope is constant here if you observe the graph, it is a straight line passing through origin and it has a constant slope. If the slope is constant, it indicates that the acceleration is constant. In first graph, acceleration is zero, whereas in second graph you have acceleration, and this is a constant value. So you can consider this graph as a uniform acceleration. Means it is the graph for a body which is moving with the uniform acceleration. Okay, uniformly accelerated body. Okay, next, coming to third graph. In the third graph, if you observe the velocity, where as the time is gradually increasing, the velocity is getting reduced. if you observe, the slope is a negative slope. Okay, so if the velocity is reducing, you can consider it as a negative acceleration or deceleration. Okay, we can consider this as a as minus delta v by delta t. So this is the, if second graph is the graph for uniform acceleration, third graph is the graph for uniform retardation, okay, or uniform deceleration, because the velocity is getting reduced slowly with the increase in time. With increase in time, the velocity is getting reduced slowly, the speed is getting reduced. It indicates that the body is in retardation. And why we are considering this as uniform means the slope of this line also is a constant value, so that's why we are considering this as a uniform retardation and this as uniform acceleration. Okay. Now we'll come to next graph, which is the fourth graph. Here, what is the information that this fourth graph is giving to us? So in order to know that, first we need to, if it is a curve, in order to find the slope of the curve, because the slope of velocity versus time graph gives us acceleration. Now if you observe here, initially the slope of this graph, if you draw a tangent at any point and find the slope of that tangent, you will get that instantaneous acceleration. Okay. Now if you observe clearly, the slope of each and every line means the slope is getting increased, means delta v by delta v by delta t value is getting increased as the slope increases. It means that it is the graph of, actually it is the graph of non-uniform acceleration, because the slope is not constant, so it is the graph of non-uniform acceleration. But in that non-uniform acceleration also, here the acceleration is slowly getting increased, because the rate of change of velocity, the rate of increase in the velocity, specifically speaking, the rate of increase in the velocity is also changing, and it is getting increased. So delta v by delta t is getting increased, which indicates that the acceleration increases. Okay, so the fourth graph indicates it is the graph for non-uniform acceleration, and the acceleration is getting increased. Okay, so this is the basic important information that we can obtain from velocity versus time graph. Now we can see one more thing, that is numerical means according to calculus, we can say that velocity is given by rate of change of displacement. When you multiply with the dt on both sides, you will get v dt is equal to ds, and integrating on both sides, you will get integral of v dt is equal to ds. So here integration, so actually integration is used to find the area under a particular curve. So here this integration is useful to find the area under velocity versus time graph. Okay, so for example, I will draw a graph with uniform acceleration with some initial velocity. So this is a straight line. So let me consider, just assume this as a straight line. This as a straight line. Assume this as a straight line. Now on the x-axis, on the y-axis you have velocity, and the x-axis you have time. Now what we can say about this graph is, here the object has some initial velocity. It means that at t is equal to 0, the object has some initial velocity, and slowly the velocity is getting increased linearly. Now if you want to know what is the displacement covered, see, if you integrate ds, what you will get, s. Therefore s is equal to integral of v dt. So what it says that the area under this velocity versus time graph. Okay, so let me put it in the words, in the form of words. area under velocity versus time graph gives the total displacement covered by the object. Total displacement, because S is obtained by taking the integration of V. Now what is the area under this graph? So up to this point, this is the maximum velocity. So up to this point, if you find the area under this graph, it gives us the displacement. Okay, so these are this is the very important and interesting information that velocity versus time graph gives us. Okay, so let me quickly recall what we have seen just now. If the velocity versus time graph is a straight line parallel to time axis, it indicates that the body is moving with uniform velocity. It indicates the body is moving with uniform velocity. If the velocity versus time graph is a straight line passing through origin, it indicates the acceleration of the body is uniform. If the velocity versus time graph is another linear graph, but with a negative slope, then it indicates that the body is moving with uniform retardation. Okay, if the same graph, same velocity versus time graph is a parabola, you can consider that the body is moving with non-uniform acceleration. And one more information, that if you find the area under velocity versus time graph, you will get the total displacement covered by the object. Okay, I hope this video helped you a lot in understanding the various graphs related to velocity versus time. Okay, if you really like this video, please hit a like button and subscribe to my channel. Thank you very much for your patience.